Hi everyone, I am Srikar. Today I am going to talk about Linux system calls, and this presentation is carried out by me and my friend Sai. So this is the outline of presentation. First and foremost, we going to see what are system calls and what are the different types in it and how they are going to occur, and then we will discuss what are Linux system calls and how to invoke them and what is the path of the system call, in how many ways it can reach the kernel, and then we will see the difference between the system calls and library functions and what are the different pros and cons of this. So let's start. What are system calls? A system call is an interface between the operating system and the process. These system calls are available as assembly language instructions. However, today several high-level languages like C allow the process to make system calls directly. Whenever a system call is made, the instructions generated by the compiler load certain registers with the parameters of the system call. For example, if we want to read the contents of a file X, the required system call may be open. Say, the actual appearance of the system call is open X. Here, X and R are the parameters, where X is the name of the file and R indicates the mode. Now, when a user wants to interact with the devices to solve his problem, and then operating system have system calls and basically manages the hardware and instructs you to do something. So their API and functions that help us to interact directly with the hardware, and there are three most common APIs. They are Win32 API for Windows, POSIX API for POSIX based op systems, and Java Virtual Machines. Categories of system calls. There are 5 major categories of system calls. They are process control, file management, device management, information maintenance, and communication. In the coming slides, I would like to explain each type. Let us assume a program being executed should be able to end up either normally or abnormally. This abnormal termination comes whenever there are bugs in the program. A process executing a specific program may require the output of another program to end up the execution of the first program. Hence, there should be the provision to load and execute that second program. The system calls under the process management category are create process and terminate process, load and execute, end and abort, get process attributes, and set process attributes. Let us consider the case when you want to type some text into a file. Then you need to open an empty file, type or write into it, save it, and then close it. Similarly, you may want to read the contents of a file. You may even write at the end of the existing file. That is, you may want to append to it. All the system calls come under the category of file management. The system calls under the file management category are open and close, read, write, append, save, and delete. This block includes system calls made by different files to access certain devices like a printer, speaker, etc. For example, if we want to print the contents of a text file, we need to request the printer. We have to ensure that printer is ready, that is, it is turned on. Then we check for the sufficiency of the paper. After our job is complete, we release the printer. System calls under the device management category are request device and release device, read device and write device, get device attributes, and set device attributes. In information maintenance, block consists of system call used for maintaining a continuous flow of information between the user and the operating system. We may want to know the system date and time. System calls exist to know the list of files in the system and also to know the number of processes being executed. Provisions are also there to know how many users are currently making use of a resources, the available memory, etc. We can also access the information relating to a particular file or directory, like what is the name of the file, when is the file or directory is created, when it is modified, what is the size of the file, and so on. The system calls under the information maintenance are get time or date, set time or date, get system data and set system data, get process file or device attributes, set process file or device attributes. Let us assume two processors on the same computer or on different computers may want to communicate with each other. Before communication between these two processes takes place, a connection must be open. The system calls get host ID, get process ID, open connection, close connection, serve to establish and close the connection between two processes. Once the connection is established, the client and the server can send and receive messages. System calls under the communication category are get host ID, get process ID, open connection, and close connection. System call occurs in different fashion depending upon the computer. Unlike other function call, to this function is not ordinary. There is a requirement of more information for the desired system call than identity. The exact requirement of the information varies according to the system operating system. So, in this example, we see how system call works. Here, user application program calls open in user mode. Now, inside the kernel mode, kernel is implementing system call open. Open is basically used to open some file to be read or written. In this slide, we are going to discuss about Linux system calls. Linux is the interface between user space and kernel space. This layer has a library in it, and this library is made up of functions which are used to communicate between user application and kernel space. For example, user application means read, fopen, and so on. Linux has about 60 system calls. This is also similar in case of Unix. Usually, programs are accessed through high-level application programs. These programs are written in high-level languages like C, C++, Java.
Hello, this is Sai, and I'm going to continue this presentation by talking about how to invoke the system calls, their path, difference between system call and library function, the pros and cons of system call. Due to some security and reliability problems, we do not directly link the user space application to kernel space. So, kernel must provide some mechanism such that user space should give a signal to the kernel that it wants to invoke a system call. For example, let us consider i386. In this, user space application will execute the software interrupt instruction. When interrupt occurs, it passes a hexadecimal value like 0x80. This instruction causes a switch into kernel space from user space, and kernel executes the software interrupt. This slide explains about the path of system call. The user application code can directly communicate with system call, or either it can communicate with library functions. And library functions will internally communicate with system call. Now, system call which communicates with kernel, and kernel further communicates with the hardware. But there is a difference between a system call and library function. The library function executes the application in user mode. But in system call, the application is shifted from user mode to kernel mode and then get executed. Let's see the difference between system call and library function. Firstly, system calls. System calls are implemented like any other ordinary functions implementation in Linux kernel. It also executes in the similar fashion like other functions, but call to the function is not ordinary. A unique procedure is required to transfer control from the user space to the kernel space. This unique procedure is called trap. Now, kernel takes a control on execution of the program until the call completes. After completion of execution, now the kernel transfers the control back to the program with return value. In system calls, the return value is generally the integer value. If the value indicates greater than or equal to 0, this shows call is success. If it shows less than 0, it shows call has been failed. Examples of these system calls are read, write, and etc. Now coming to library calls, library functions is also an ordinary function. It is in user space present in the library, which is an external to the program. In contrast with system calls, call to library function is ordinary. Examples such as fopen, printf comes under library functions. In library functions, the return value are in the form of pointers, and the null return values indicates the failure. This slide shows about the pros and cons of system calls. Let's see the advantages of system calls. System calls can provide more control on the kernel space to the user. Library calls can provide wrappers. So wrappers are the functions whose main purpose is to call a second function. Coming to the disadvantages, library functions may have a overhead system calls, sometimes may expose the underlying system dependency. This program creates a shell and executes respective instructions passed. Let us see how these system calls are passed in this program. First, the program starts with an header files like hash include stdover.h, hash for printf statements, and hash include stdlib for exit commands, and hash includes syswait for the wait command, and string.h and stdbol.h for string and boolean commands. So we have declared 4 variables like I, status, r, and st. We use fork method in this program, and forking is only for the continuous iteration process, because the single process is divided into multiple processes so that the execution will be easy. And so while we use the fork process, we have declared the status also, since the status keeps the information regarding the process, and the process has been created. So then we assigned a boolean loop to true, and we created an array of characters. So when the loop starts, so here it prints a bash statement. So we here use a file management system called fgets, where fgets is a function where the input can given from the keyboard or any from a file. When the fork function has been given, the process will be divided here, like for parent process and child process. So if the process is greater than 0, then it's a present process, that is it shows the status of wait, and whenever the process is equal to 0, then it's the child process where it's going where the status is equal to 1, so it's going to start or execute first. Since the priority is 1, so it's going to execute first. If the ultimate result of the process is less than 0, then the forking process, there's a problem in executing this forking process. Let us see the output of the program, and this program executes the commands according to the user. Like if the user has given the ls, that is going to show the list of directories contents on the file information, and ls minus a like list of all the hidden files, and ls minus s like the list of the name and the size of each file in the directory, and ls minus f gives the list of files and subdirectories, and ls minus r which shows the list of the chain of directories starting from the current directory.